Dear students, good morning. In the last class, we discussed about pointing theorem. In that pointing theorem, we have pointing vector. That pointing vector is given by P is equal to E cross H, where if you see the wave solution, this E is equal to E naught into e to the power minus alpha z cos of omega t minus beta z. Similarly, H is equal to H naught e to the power minus alpha z cos of omega t minus beta z minus theta neta. How we got this theta neta? Actually, we have the relation between E and H. That is mod E by mod H is equal to neta. Mod E by mod H is equal to neta. So if this neta is complex conjugate, in that case there exists angle this theta neta, or else we can write H is equal to E by neta. H is equal to E by neta. Then you have this neta, that is mod H, can be written as what? That equal to mod E by mod neta at an angle of theta neta. So that's why it can be written as what? E by neta, which is equivalent to E by mod neta at an angle of theta neta. So that's why actually here it is not H naught. So it is E naught because here we consider theta neta. Then we can find this pointing vector. That pointing vector is equal to what? P is equal to E cross H. Then we have the multiplication of these two. That is what? E naught into E naught, that is E naught square e to the power minus 2 alpha z cos A cos B means that is cos of omega t minus beta z cos of omega t minus beta z minus theta neta. So it is in the form of, actually you can see here it is cos A form and it is cos C. We know that cos A cos B is equal to what? 1 by 2 cos of A plus B plus cos of A minus B. So that's why here this P can be written as, okay. So that is P is equal to E cross H, that is equivalent to what? E naught square e to the power minus 2 alpha z, and that cos A cos B can be written as what? Half into cos of A plus B, that is omega t plus omega t is 2 omega t minus beta z can be added, that is 2 beta z minus theta neta. So that is the addition, and subtraction, that is cos of A minus B, that is cos omega t gets cancelled, beta z cancel. You have what? Theta neta, that is cos theta neta. Actually, this is the instantaneous value of the pointing vector, but we required, in order to get the actual value, we need what? Average value. That average value can be obtained, that is P average is equal to 1 by 2 integral 0 to t, this instantaneous value, that is P dt. And if you simplify this one, we will get, actually that is 1 by 2. So this constant 1 by 2, and E naught square is also constant. E to the power minus 2 alpha z is also constant because integration with respect to t. So this cos t, this one, okay, average value of cosine function gives what? 0. And this cos theta neta integration with respect to t gives what? Cos theta neta. Integration value is t, that is limits from 0 to, actually it is t, 0 to t. Now, after simplification, we will get, that is 1 by 2 E naught square e to the power minus 2 alpha z cos theta neta into t. Actually here we have 1 by t. So actually I forgot to write that 1 by t here. So here also we have 1 by t. So this t gets cancelled. Finally we got that is E naught square e to the power minus 2 alpha z cos theta neta 1 by 2. So this is the what? Average value of the Poynting vector for conducting medium. For non-conducting medium, theta neta value is 0. Alpha is 0. This non-conducting medium is also known as what? Lossless medium. For lossless medium. By substituting this, you will get P average value as what? 1 by 2 E naught square e to the power minus alpha value is 0, that is e to the power 0, that is 0, cos theta naught value is like this. That is 1 by 2 e naught square by 2. 1 by 2 e naught square. Actually, I forgot to write one thing, that is what? E naught square divided by neta. Here we forgotten this neta, because if you see this one, that is actually h is equal to E naught by neta, mod E by neta. So therefore, actually I forgot to write this h, because h can be written as what? E by neta. E is this part and by neta, and this 1 by neta should be projected here also. Actually I forgot to write that part. Here also we need to mention, I am writing that 1 by neta here. 1 by neta here. Here also that 1 by neta should be presented. Here also this one. Okay, therefore here we can write actually here also that 1 by 2 neta. Hence P average can be written as conclusion. P average can be written as P average is equal to what? 1 by 2 neta E naught square. Or else we can write this one as 1 by 2 E cross H. If E and H are real, we can write like this. If they are complex, if they are in the complex form, we can write this one as 1 by 2 E cross H conjugate. This is the expression for the P average. By using this P average value, we can determine the average power radiated from the given surface. That average power, that is W is equal to integral P average dot ds, where P average is equal to what? 1 by 2 E cross H conjugate. If they are real, we can write simply 1 by 2 E cross H. So that is E by 2. H can be replaced with what? E by neta. Then it can be written as what? 1 by 2 neta E square. Okay, so this is about the E average, that is Poynting vector. So in today's class, what we have discussed now, so going to this Poynting vector is given by E cross H. E can be written like this. Then H can be written as what? E by neta like this. As we have the angle, that is for the conducting medium, neta can be written as what? As neta is, we know about neta. Already we derived in the offline class only. So that is what? Neta can be written. Neta is equal to under root j omega mu by sigma plus j omega epsilon. Please remember this equation. Actually, we derived this one in the classroom itself. Theta equal to under root j omega mu by sigma plus j omega epsilon. As it is complex quantity, we can write this as what? Neta is equal to its magnitude mod neta at an angle theta neta. As it is present in the denominator, when it went to the numerator, it can be written as what? At angle So that is actually when it is presented in the numerator, it can be taken as what? Minus theta neta. E by mod neta at an angle theta neta here minus theta neta. So that's why here, if you multiply these two, we can write this one as what? Cos of omega t minus beta z theta neta. Next, go to simplification. If you go to the simplification, we got E naught into E naught square, e to the power minus alpha z into e to the power minus alpha z, e to the power minus 2 alpha z by neta, that is magnitude. And cos A, cos B can be written as what? 1 by 2 of cos A plus B, this one A plus B, and this one is cos A minus B. Omega t gets cancelled, beta z cancel. Here they are added, here they cancelled, and the remaining term is what? Cos theta. As it is minus, minus becomes plus. And here P average is equal to 1 by 2 integral 0 to t p dt. So here we can write what? That is 1 by t, and here already we have 1 by neta, and I have written that only. And here you have 1 by 2. E naught square, these are the constants, and average value of this cosine term with respect to time gives what? 0. As it is constant, here we will get t only. So that is limits are from 0 to t. Finally, after simplification, we got 1 by 2 neta E naught square e to the power minus 2 alpha z cos theta neta. This is for what? Conducting medium. This is for conducting medium. For non-conducting medium or for lossless medium, theta neta value is 0 and alpha value is 0. Then we will get P average equal to 1 by 2 eta naught square. Now let us see characteristics of the EM wave in good conductors and good dielectrics. Before entering into the topic, let us see another parameter, that is dissipation factor or else loss tangent. Loss tangent. It is also known as dissipation factor. Dissipation factor. This factor is used to decide the given material is good conductor or good dielectric. Dissipation factor. It is represented by dF. This dF is basically defined as a ratio of the magnitudes of conduction current density to the displacement current density. We have the conduction current density, that is what? Sigma into E, and displacement current density epsilon into dou E by dou T. Dou E by dou T. We know that E equal to what in phasor form? E is equal to, E can be written as what in time domain? Time domain phasor form, E naught into e to the power j omega t. If you substitute here, that is Jc equal to what? Jc is sigma into E naught into e to the power j omega t. That is sigma into E only. And JD is equal to what? Epsilon into dou by dou T of that E. E is what? E naught into e to the power j omega t. And this gives what? Epsilon into j omega into this E naught e to the power j omega t. Finally, we will get j omega epsilon into E. And if you take the magnitude of this JD, we will get what? Omega epsilon into E. So therefore, here only I am taking. So therefore, here we have this dissipation factor, that is dF or loss tangent, is equal to what? Jc is magnitude of Jc, that is sigma E. Magnitude of JD is what? Omega epsilon into E. So this one cancel. Finally, dissipation factor is equal to what? Sigma by omega epsilon. This dissipation factor helps us to determine whether the given medium is good conducting medium or good dielectric medium based on the sigma and epsilon values at a given frequency. How we can determine the given medium is good conductor or good dielectric based on this dissipation factor? Actually, we have dissipation factor, that is dF is equal to what? Sigma by omega epsilon. Let us take this condition, that is sigma by omega epsilon is greater than 1. In this case, medium is treated as what? Good conductor. Medium or material is treated as what? Good conductor. And if sigma by omega epsilon is less than 1, then medium is treated as what? Good dielectric. Good dielectric. Now we have the doubt. Suppose if this one is sigma by omega epsilon is equal to 1, in that case, we will get a frequency. That frequency is known as a transition frequency. That frequency is known as what? Here omega t is angular transition frequency. Angular transition frequency. At this frequency, angular transition frequency, at this frequency, conduction current equal to the displacement current density. It is what JC equal to JD, as it is the ratio. Okay, magnitudes of the conduction current density equal to the displacement current density. So this is about what? Dissipation factor. By using this dissipation factor, we can derive the characteristics of the EM wave characteristics in good conductor. Let us go to the EM wave characteristics. EM wave characteristics in good conductor or in a lossy medium. Good conductor can be taken as what? A lossy medium. Here, what is the condition for the good conductor? Sigma by omega epsilon is greater than 1. Now we have gamma. Gamma equal to what? Under root j omega mu into sigma plus j omega epsilon. As you substitute this sigma by omega epsilon is greater than 1. So this term that j omega epsilon or omega epsilon can be neglected. We have what? J omega mu sigma. We know gamma is what? A sum of attenuation constant and phase shift constant, that is alpha plus j beta. That means here it has a real term and imaginary term. So for that, I am taking like this, that is multiply and divide with 2, that is 2j omega mu sigma by 2. I will do this derivation here itself, that is alpha plus j beta, which is equivalent to omega mu sigma by 2. I am writing the 2j plus 1, adding and subtracting, and minus 1. That minus 1 I am writing like this, that is j square. And if you see this one, it is in the form of like this, that is omega mu sigma by 2, 2j into 1, plus j square, that is minus 1, plus 1 square. It is in the form of what? A square plus b square plus 2ab. A square plus b square plus 2ab. So that's why it can be written as what? Omega mu sigma by 2 a plus b whole square, that is 1 plus j whole square. Now we can write this one, 1 plus j into under root omega mu sigma by 2. So therefore, by equating real and imaginary, we will get real term, that is alpha omega mu sigma by 2, and beta, that is also under root omega mu sigma by 2. So this is for what? Good conducting medium. Wave characteristics in a good conducting medium, that is alpha value and beta value. Now we'll see another characteristics, that is what? That is neta. Neta is equal to already we have the expression, general expression we derived, j omega mu divided by sigma plus j omega epsilon. So actually it is equivalent to what? Mod neta at an angle theta neta, as it is the complex quantity. Now, as you know, sigma by omega epsilon is greater than 1. This can be neglected. This j omega epsilon term can be neglected. Therefore, neta is equal to what? Under root j omega mu by sigma. Again, same procedure. So now we can take multiply with the 2 and divide with the 2. You will get this one as real term and imaginary term. That can be written as what? Real and imaginary terms are equal. That is omega mu by 2 sigma plus j omega mu by 2 sigma. So it has a real term, that is Rs, and imaginary term, that is Jxs. So this is the expression for what? Neta. And what about the angle? That is theta neta for the good conducting medium. Tan inverse of imaginary by real. So both are equal. So that's why tan inverse of 1 here we will get, that is equal to what? 45 degrees. For good conducting medium, theta neta value is equal to 45 degrees. Therefore, E can be written as what? E naught into e to the power minus alpha z cos of omega t minus beta z. Let us say electric field is along x direction and magnetic field is along y direction and wave traveling along z direction. That is h equal to what? H naught. That can be written as what? E naught by neta into e to the power alpha z. And here you have the theta neta. The theta neta value is 45 degrees. So therefore we can write cos of omega t minus beta z. That angle, phase angle is 45 degrees. As it is in the numerator, we can write minus 45 degrees AY. So this is about what? Wave characteristics in good conductors. Good conductors. What are the characteristics we have derived? Alpha and beta are equal. Alpha and beta are equal. So here alpha value is what? Omega mu sigma, j omega mu sigma. Additionally, we got by 2. Okay, so that is alpha and beta. Why I am saying this? Why I am considering this two? So actually, j omega mu sigma is the gamma value. Then we have real term and imaginary term means what? Additionally, we got by 2. Here also same thing for the this neta also. Neta is what? Actually, j omega mu by sigma. Additional factor is what? 1 by 2. So that is under root j omega. Actually, I forgot to write this one. But it is actually root. So let us take here root. Here also root. Okay. Once verify this alpha also. Alpha and beta, we have to write root. Okay, root is there. So this is about what? Characteristics of. We have another parameter. So that is known as skin depth. That is known as skin depth. That skin depth is related to alpha. Generally, that skin depth is given by delta is equal to 1 by alpha. We can prove this one in a very simple manner. Actually, E for the lossy medium, E can be written as what? E naught into e to the power minus alpha z with respect to the distance. Okay. Here we consider only with respect to distance. Actually, the amplitude variation is like this with respect to distance. Skin depth is the distance at which wave amplitude is equal to the electric field amplitude is equal to 1 by E of its maximum value. It is defined as what? It is the distance. Distance means what? If z is equal to delta, if z is equal to delta, E becomes what? 1 by E of its maximum value. What is the maximum value? E not only is the maximum value. It is the initial value or maximum value. So therefore, here, if z equal to delta, E becomes what? 1 by E of, substitute in this one. Here we will get what? E is equal to what? E becomes what? 1 by E of its maximum value. What is maximum value? E naught. At what distance? E naught into e to the power minus alpha. Z value becomes what? Delta. So here E naught gets cancelled. 1 by E can be written as what? E to the power minus 1. And here e to the power minus alpha delta. Here E bases are equal. Therefore, power should be equal. Minus minus cancel. That alpha delta equal to what? 1. So therefore, delta equal to 1 by alpha. This delta is known as what? Skin depth. Skin depth. It is another parameter of the EM wave. So it is defined as what? It is the distance at which wave amplitude, wave electric field amplitude becomes 1 by E of its maximum value. 1 by E of its maximum value. According to this, delta is equal to what? 1 by alpha. Just now we derived the characteristics of what? That is delta is equal to 1 by alpha. Already we have the alpha. Alpha equal to what? Under root omega mu by 2 sigma. Oh, sorry, it's correct. Alpha equal to under root omega mu sigma by 2. So this is the alpha value. This is the alpha value. Once verify, there it is. Alpha, that is under root omega mu sigma by 2. Now we have to write this one delta in terms of this omega mu sigma, because we have written alpha in terms of what? Omega mu sigma by 2. Therefore alpha can be written as what? Therefore delta can be written as what? Delta is equal to under root 2 by omega mu sigma. This is the delta. Okay. Now we will see another topic. Wave characteristics in good dielectrics. Just now we discussed the wave characteristics in good conductors. We have to discuss the wave characteristics in good dielectric. Wave characteristics. Wave characteristics in good dielectrics. For good dielectrics, for GD means good dielectric, sigma by omega epsilon is less than 1. For that, gamma equal to what? Under root j omega mu into sigma plus j omega epsilon. So then gamma can be written as what? The sigma can be neglected here, as sigma by omega epsilon is less than 1. So sigma is less than omega epsilon. Then it can be written as what? Under root j into j omega mu into j omega epsilon. It can be written as what? J into j square, that is root j square can be written as j. Omega into omega square, root omega square can be written as what? Omega under root mu epsilon. Here we have alpha plus j beta. Alpha plus j beta. So by equating real and imaginary, alpha equal to 0 and beta equal to what? Beta is equal to omega under root mu epsilon. Mu epsilon. Similarly, here neta equal to what? Neta can be written as what? J omega mu sigma plus j omega epsilon. As sigma is less than omega epsilon, this can be neglected. So neta can be written as what? Under root j omega mu. Here sigma is neglected. J omega epsilon. So j omega gets cancelled. Neta equal to what? Under root mu divided by epsilon. So here it is what? Real. It is not complex. And that's why here neta can be written as what? On neta at an angle. Theta neta value is 0. Theta neta value is 0. So this is about alpha and beta. Wave characteristics in good dielectrics. Similarly, as alpha equal to 0, what about delta? Delta is equal to 1 by alpha. So therefore, delta is equal to what? Infinity. Delta is equal to what? Infinity. Okay. Since delta equal to 1 by alpha. So these are the wave characteristics in good dielectrics. Good dielectrics. And one more thing, for the good conductors and good dielectrics, we can also find this phase velocity. That phase velocity is given by Vp equal to omega by beta. Let us write beta. Beta is equal to what? Beta equal to under root omega mu sigma by 2 for the good conductor. It is for GC. And beta is equal to, what is beta? Beta is equal to omega under root mu epsilon. That is for good dielectric. So therefore, phase velocity for good conductor Vp is equal to omega by beta. That is what? Vp, that is omega, and here root omega mu sigma by 2. So it can be written as what? 2 omega mu by sigma. So this one is the phase velocity for the good conductor. It is for good conductor. And for good dielectric, Vp is equal to what? Omega by beta. Omega is okay, omega beta omega under root mu epsilon. Omega into under root mu epsilon. So omega gets cancelled. So this is the phase velocity for the good dielectric or lossless medium. Okay. For free space, we can find this alpha or beta also. Free space is treated as what? For free space, wave characteristics. For free space, sigma value equal to 0 and epsilon equal to epsilon naught, mu is equal to mu naught. That means the sigma can be treated as 0. Let us write gamma. Gamma equal to what? Under root j omega mu sigma plus j omega epsilon. Substitute sigma value as 0 and mu value as mu naught and epsilon value as epsilon naught. So then you will get this gamma as what? Under root j into j square omega square, mu as mu naught and epsilon as epsilon naught. And it is alpha plus j beta. So therefore here it can be written as what? J omega under root mu naught epsilon naught. Therefore alpha equal to 0 and beta equal to what? Beta is equal to what? Omega under root mu naught epsilon naught. Now let us write this intrinsic impedance also. Neta equal to what? J omega mu by sigma plus j omega epsilon naught. As sigma value is 0, we will get sigma value is 0, epsilon is epsilon naught, and mu is mu naught. Finally, we will get this neta as neta naught, that equal to what? Under root mu naught by epsilon. If you substitute mu naught and epsilon naught values, you will get here this value. Actually, this value is equal to 125. This is the impedance. As it is impedance, units are ohms. 125 ohms for free space. These are the characteristics, EM wave characteristics. The means gamma, neta, and neta naught. Of course, from the gamma we have alpha and beta. These are the characteristics of the EM wave in free space. Okay. So in today's class, what we have discussed? First, we have discussed Poynting vector. That is P equal to what? E cross H. From that, we derived P average. P average equal to what? 1 by 2 E naught, 1 by 2 neta E naught square. And then after, for the complex conjugative quantities, for the complex, if E and H are in terms of the complex form, then we can write P average equal to what? 1 by 2 E cross H conjugate. Otherwise, we can write P average equal to what? 1 by 2 neta E square. So what is the importance of this P average? We can determine the average power flow from the given surface by using this P average, that equal to what? Power flow equal to what? W equal to integral P average dot ds. Next, we discussed about loss tangent. That is what? It is defined as ratio of the magnitude of the conduction current density to the displacement current density. Finally, we got this dissipation factor as what? Sigma by omega epsilon. What about the importance of this one? Sigma by omega epsilon is greater than 1. Material or medium is treated as what? Good conductor. If it is less than 1, then material or medium is treated as good dielectric. If this one is equal to 1, in that case, we will get a transition frequency, that is omega t, which is equivalent to omega t is equal to 2 pi ft. This ft is known as what? Transition frequency. At that frequency, conduction current density equal to the displacement current density. EM wave characteristics in good conductor. For good conductor, sigma by omega epsilon is greater than 1. For this case, alpha equal to beta. And similarly, neta equal to Neta equal to what? RS plus JXS, where RS and XS in magnitude point of view, they are equal. That equal to what? RS equal to omega mu by 2 sigma. So here we have neta value. And next, delta equal to 1 by alpha. That is, we derived delta is what? Skin depth. That is the distance at which amplitude of the electric field intensity. It is the distance at which amplitude of the electric field intensity equal to the 1 by E of its maximum value. From that, we derived delta equal to 1 by alpha. Wave characteristics in good dielectrics. So for good dielectric, alpha equal to 0, beta equal to omega under root mu epsilon. And neta equal to what? Under root mu by epsilon, it is real. Similarly, for the free space, we derived the characteristics. And of course, we discussed phase velocity also. So that is omega by beta. Then after for free space, EM characteristics like this. Alpha equal to 0, beta equal to like this, and neta value is 125. And now one important relation we need to discuss about in good conductor. So that relation is nothing but what? This delta, we know about delta is equal to what? Skin depth equal to 1 by alpha. From this, we can derive the relationship between skin resistance and this alpha or delta. Okay, we can write skin resistance in terms of delta also. So that is given by, actually we have neta for good conductor. For good conductor, we will see the expression for good conductor, good dielectric. So this one is skin depth. Okay, here we have the what? Skin resistance, and this one neta. Neta equal to what? Under root omega mu by 2 sigma. Actually, here it is wrong. J outside of this root. So neta, what is neta actually? For good conductor, that is omega mu by sigma, j omega mu by sigma. If you write this one in the complex form, you will get what? Real and imaginary. So that is RS plus JXS. RS plus JXS. So that RS is equivalent to what? Under root omega mu by 2 sigma plus J. Here I am writing correctly. So that is actually in the previous, I wrote this one inside the bracket, inside the root, but it is outside of the omega mu by 2 sigma. Now I have RS. I have to get the relationship between this RS and the skin depth. That is RS. RS is equal to what? Under root omega mu by 2 sigma. But I know alpha for good conductor. Alpha equal to what? Under root omega mu sigma by 2. It is omega mu sigma by 2. Here sigma, omega mu sigma by 2. If I write here sigma by 2, I will get what? This alpha. So therefore, I am writing this RS as like this. That is under root omega mu by 2 sigma into sigma by sigma. Then I can write this one omega mu sigma by 2 sigma square. Then I have what? RS root 1 by sigma square can be written as what? 1 by sigma. Remaining term is what? Omega mu sigma by 2, which is equivalent to what? Alpha. This alpha only. So therefore, it is what? Alpha by sigma. RS. RLs. RS is equal to what? 1 by sigma delta. This is known as skin resistance. Skin resistance is inversely proportional to the skin depth. Actually, resistance opposes the flow of current, and delta RS opposes the flow of current. So that's why delta can be treated as what? Strength of the EMF. This parameter can be related as what? It is nothing but what? It indicates the strength. Okay, it is related to the strength. So in today's class, We have discussed average Poynting vector and wave characteristics in good conductors, wave characteristics in good dielectrics, as well as this skin depth also, relationship between skin depth and skin resistance. Okay, I'm stopping today's class here. Please study these parameters thoroughly. Okay, thank you.